Hi friends, very good morning to all of you. Welcome to Rams Academy. First, I would like to thank all my viewers who have really seen, watched my previous videos, and they have given very good comments. And these comments have motivated us to go ahead with our work. We are very happy for that, and we would like to in future also we will be coming out with more videos, which will be definitely, we assure you, it will be very much useful to you. Whether you are a student or really a technician or an engineer, and definitely the informations we have collected from many sources, many people have contributed for that, and I take this opportunity to thank all those people also. So this team is really working very hard. What best we can do in this Rams Academy, we are doing it. Thank you. And then moving on to the next video. In this video, I would like to discuss about SMPS. First of all, I would like to introduce SMPS like this. The expansion for SMPS is nothing but switched mode power supply. This type of power supply has started becoming popular in India in the year 1980. Those days, there were a lot of TVs already there, but when they started broadcasting the television in color, the color TV started coming with the SMPS. To be very frank, only from those days I started realizing there is one more power supply called SMPS. Like that, SMPS has become everywhere. You'll be able to see SMPS right now. Maybe in computer, maybe in a charger for a cellular phone. Everywhere you'll be able to see only SMPS, because there are a lot of advantages in SMPS, switched mode power supply. Earlier, what happened is we were using ordinary type of linear power supplies. In those linear power supply, the thing is becoming very high. It will be getting heated. Energy dissipation is more. For information, when you apply either a linear regulator or SMPS regulator, whatever it is, it will take the power supply from domestic 1 to 30 volts AC, and then it will give out all DC power supplies, all are regulated one. In that condition, when it is regulating, definitely it consumes some power. But this consumable power in linear regulators are more. They are dissipated as heat. But in SMPS, that consumable power is very, very less. Therefore, SMPS are not at all getting heated. That is an advantage. Another thing, this SMPS is going to have a smaller size, because there is no power supply transformer. A circuit is going to work under higher frequency. The filtering capacitors can be of smaller value. That is an advantage. Smaller value in the sense size is going to be small. Overall, the transformer is also small. The power supply is not going to get heated. The filter capacitors are very small. Therefore, overall circuit is going to be very small only when you compare with the linear regulator. And another thing, regulation is very good. Regulation in the sense, I have discussed this regulation in input characteristics as well as in output characteristics of ordinary regulator. That is, it should be able to supply sufficient current rating. All these things are very easy in SMPS. It may accept larger changes, it will not pass on these changes. Like that, stabilizer, SMPS regulators are going to be very rugged one, small and reliable. They are not failing. The transformers type of power supply, as the power supply is getting heated, there may be diodes, there may be capacitors, resistors, like that. All these things are going to fail because of heating. Like that, all these difficulties are not going to happen in SMPS. That's what we are going to see now. SMPS expansion is switched mode power supply. To understand a regulator, we have to understand this. That is, for information, if you have a larger DC supply of higher voltage, 300 volts DC, when you want a smaller one, that is, let it be 12 volts. This is the one we have. This is the one we are going to have. This is being applied to a particular gadget to make it work. This is what, after rectification of the incoming power supply, we are going to get 300 volt DC. Instead of going for a regulator type, series regulator, shunt regulator and other things, definitely they are going to get heated. They are going to use very high power transistors and other things. Instead, somebody has understood that this can be converted into this in a simple understanding. I have understood this way only. Now understand, this is an area. We have got a 12 volt power supply with respect to time. We have got a 300 volts power supply with respect to time. In that condition, this is what we want. In this graph, try to understand, this is the area we want. This has got the height as well as time. Okay, so this is also having this much. When you want to convert to this, we want to extract this much area only from here. This is possible to have like this. Instead of continuously passing all these things, I can have a intermittent regulation, like I switch on for some time like this, and then I switch on for some time like this, and then I switch on for some time like this, like this, like this, like that. Like that, for this timing, this is of course larger this thing. I am not going to switch on, I am going to switch off. This is being switched off for some time. In that condition, this is the area. This is the area. The area which I am having slanting lines are nothing but switched on timings. Like that, this one, this one. Suppose 1, 2, 3, 4, 5. When you add all the area, if it is equal to this, are we able to get a transformation? You have got a larger one. From that I want to extract this only. That is nothing but this is the area equivalent. Okay. When this is the case, okay. Now, of course, this cannot be equal to this. Instead, what I am going to do, this is changed and filtered out using capacitors like this. When I apply this voltage, capacitor will charge here and it starts discharging, and then charge here like that. When you are using a capacitor across this, it is going to charge and discharge. Charge, discharge. In that condition, that is going to have what voltage I want here, and continuously we are going to get it. Therefore, please understand that though we are having a larger area power supply, by switching on for a regulated timing, predetermined time, after filtering out, that can be equivalent to 12 volts and can be supplied to a particular gadget. This is what SMPS is doing. That is what this is doing. Please understand switching. This voltage is switched. Okay? This is the mode. Okay? This is a power supply. This is being switched for a particular timing T1, T2, T3 duration. All T1, T2, T3 are equivalent. But if this timing is variable according to the voltage what we want out of this, if we are having a variable time duration, and then we are able to make it equal to either 12 volts or 15 volts or 24 volts or whatever it is, switching duration has to be changed. We cannot switch for a duration of equivalent timing like T1, T1 like that, but that may develop 12 volts only. But if you are increasing or decreasing T1 to T2 or T1 to T3, like that, if you are going on increasing the duration, voltage may be higher, or when you are reducing the timing, the voltage become lower. Like that, switched mode power supply is nothing but a constant DC higher voltage is being switched for a necessity, for a particular timing, continuously and filtered out using capacitors. Therefore, by opting for a larger duration for a higher voltage and smaller duration for a lower voltage, this can be converted into a lowest DC voltage that can be supplied, that can be applied to a gadget to make it work, to give a constant performance. Therefore, switching is happening from here to here. Mode is nothing but how we are going to adjust this timing, that is going to be the power supply. Switched mode power supply. Now, how this is nothing but when you are adjusting the timing, this timing and this timing, that is called duty cycle. Duty cycle of the switching is being changed for the requirement of the voltage in the output side of the SMPS. So this is the basic. Without understanding this, we cannot go and learn anything by looking at a circuit. That's why I explained about it. This is a basic thing. There are two types of switching, two types. One, duration can be changed. Frequency can be constant. Frequency in the sense, the frequency is defined by this timing. On period and off period. 1 by on period plus off period will give you the frequency of operation. Therefore, this frequency is kept constant, but on period and off period are changing. If on period is changed, off period is going to reduce. Like that. If you reduce the on period, off period is going to be large. Like that, duty cycle is changed. That is the first type. In the first type, you can make this SMPS to be changeable according to the duty cycle. Second one, the timing can be kept constant, but frequency can be changed. Duration is fixed. Frequency is changed. That is another type of SMPS. Please understand that after switching off this voltage, this pulsating DC is going to be fed to a transformer, and the secondary is connected to a rectifier and filter, and the output is taken to the real gadget. Here, of course, we get this voltage and we are switching. We are not going to switch by adjusting adjust the frequency of operation. That is on plus off. Period is either reduced or increased. From that, please understand that F, which is applied, amplitude is same. When frequency is increasing, the secondary voltage will be increasing. If the frequency is coming down, secondary voltage will come down. Therefore, this is the basic principle. Please understand that in every transformer, if you have a transformer of 220 volts and a secondary voltage 12 volts for 50 Hz operation, and for the same transformer, instead of feeding 220 volts 50 Hz, you apply 100 Hz. You check up the voltage in the secondary. That voltage is going to be little more. Reduce the frequency. You see, the voltage in the secondary is going to it will be lower than the previous value. The basic understanding is like this. In a transformer, secondary voltage is produced by cutting the magnetic lines. Voltage produced in the secondary is nothing but rate of change is proportional to rate of change of flux occurring in the transformer. If the rate of change of flux is changing, if the cutting of a magnetic lines is very, very, very fast, the voltage produced in the secondary is going to be large. The same way here, when you are increasing F, secondary voltage will be larger. If the frequency is reduced, this is going to be lower. According to the necessity of the voltage, this F can be varied from a lower value to a higher value. So this type of SMPS is also, this type of SMPS will be able to produce a constant voltage in the secondary by adjusting this pulsating DC. Without adjusting the amplitude, I am going to adjust only the frequency of operation. In the first one, I am not going to adjust the amplitude. I am going to keep the amplitude constant, frequency constant, but duration, either on period and off period, I am going to change. Then the condition that will be able to change the secondary voltage. So this is the basic principle behind the SMPS transformer, how it is going to give a regulator voltage at the secondary. So with this, I would like to stop. I would like to go into the very important details of the circuit by drawing a circuit and explaining to you in the next part. Thank you.